Ladies and gentlemen, welcome to Eplan and CDON's Virtual Fair 2017. My name is Anders Donos. I'm the director for our professional service business in Asia Pacific, and I have today the pleasure to introduce Eplan Electric P8. Before I do that, I would like to just inform you about the fact that you, of course, through the entire presentation have the possibility to ask questions through the chat windows. So, of course, my colleague is standby to also ask to answer all the questions, of course. Also, myself will be available after the presentation for any type of questions. So please feel free and please ask questions to myself and my colleagues. So, when we talk about electric P8, we talk about electrical engineering. And talking about the electrical engineering process as overall, we talk about detail engineering or basic engineering, for example, as well as creating manufacturing documentation as overall. As we see here in the picture, we have electric P8 as a central part, doing detail design or basic engineering by single line or multi-line. Of course, fully integrated to the overall engineering platform, integrating to other type of engineering disciplines like fluid, like pre-planning for instrumentation, controls design, for example, and of course, fully integrated as well to our Eplan data portal. As for those who doesn't know the Eplan data portal, this is our seamlessly integrated manufacturing data, where we have more than 800,000 data sets available from more than 175 different manufacturers. This is, of course, essential to very quickly speed up the engineering. And this is also why we talk about out-of-the-box solution, partly where you don't have to really start from scratch. You have a lot of data already available, such as manufacturing data, but also, of course, all the type of reports that you also can see on the right side. So once you have done your detailed design, you also want to produce manufacturing documentation like bill of materials, for example, or wire list or cable diagrams related to production or commissioning, or it could be, of course, maintenance. All this is fully automatically through the electric P8 environment. And of course, if you want to also output, for example, labeling data, it could be directly to various labeling machinery, but also to general formats like Excel, for example. It could be device list or wire list or panel tags, etc., etc. For us also, it's important to integrate to other technologies like PLC software. So for us, the bidirectional interface to the electric P8 environment is very essential to maintain data consistency between the PLC software and the IO list, descriptions, bus topology, rack layouts, and so on and so forth, which you can seamlessly integrate and reuse between the detailed design in electric P8 as well as from the PLC software. So all in all, these are very essential parts through the electric P8 environment. Of course, today we don't have time to go through all the different topics that is the capabilities of our electric P8 environment. So I'm going to focus on our short presentation today about flexible design method. This is, I believe, a very important aspect to the electrical P8 environment, to be able to start at any time through the project in, for example, single line, or in the panel, 2D panel, or in the multi-line, for example, and all is data consistent between the different environments. When we talk about flexible engineering method, let me go into the software and give you a live demo to give you some more further information. So this is our electric P8 environment, where we have here a sample project from a grinding machinery. We see on the left side the page structure, which is based on the IEC 81346, which is based on function, location, and product. And that's also why you can see the certain structure that we have here. Of course, you have also any kind of standard also available or supported. So if you think from, for example, Ghost in Russia, or you talk about the North American market with NFPA, you talk about the Chinese market with GB or JIS from Japan and so on, all out of the box available from the electric P8 environment. So when you talk about, for example, creating here complete empty page. You have, of course, the capability of talking about different flexible design methods like just traditional symbol-oriented design, which is very known by the most, utilizing symbol libraries to be able to build the different schematics accordingly. And later on, of course, also maybe add part numbers to be able to generate a bill of materials in the very end. All this is fine, of course, but I would like to give you some other input to design methods. So once you build certain circuits, of course, you also find that you very often reuse them. And instead of doing, let's say, copy and paste, we also could say what we talk about typicals, reusable typicals. And for us, this is insert window macros in the system. And in this case, I will select here on motor drive. Based on this, you can actually, within that typical, also save several different graphical representations. So this will help you to maintain, in the very end, all these macros. And it will also help you to very easily speed up your engineering based on the same. Not only graphical representation is important, of course, but here we can also define what kind of kilowatts the motor have. And based on this, if we, for example, here select a 2.2 kilowatt motor, it will select the right size of cable, the right motor load switch, and so on and so forth. This, of course, helps us to standardize the reusability of the typical. So if you have several engineers working in the projects, you can, of course, have one single source of data which you know is correct and therefore generates high quality data. So I select also here to number the drives. I will select and place also some additional, let's say, okay, 7.5 kilowatt. We place another one which is 0.75, and okay, that's the last one. This will be our 7.5 kilowatt. So now your customer also calls you very late in the project saying, well, sir, we have changed one of the motors here from 7.5 to 5.5. You need to change. So instead of going into the motor, going into the cables, into the wires, into the motor overload switch, and so on and so forth to change it, I can simply just assign a new value set, selecting the 5.5, and through the entire typical, you change now all the values and all the data. And of course, this affects also the part numbers represented also in the bill of materials later on. So utilizing typicals is an essential part of the reusability to enable efficient engineering, I believe. So as we see, this is what we talk about typical, but of course, as you also build your parts library, so here I have an example of a part library where we have various different components. These are something that, of course, you can build up, but also, of course, import from various different external resources. So in this case, I would like to utilize, for example, here, a motor load switch. I see also the graphical preview with the auxiliaries. And with a simple drag and drop, I can just drag it into the schematic and place it. What is now essential going into this device is, of course, that all the relevant parts information is here for my bill of material, but not also the bill of material. We can see, for example, here, if I place also the component in a layout, I can also have the height, width, even depth, and if we talk about a 3D environment. So essentially here, this is interesting due to the fact that, of course, as a central part of the company, you have one single source of data which you are utilizing. I mentioned earlier that one very important part of the efficient engineering is to utilize our data portal. So utilizing our data portal, I can populate here on the right side, again, completely seamlessly integrated, where I find most of my used different manufacturers. As I mentioned, it's more than 175 different manufacturers with more than 800,000 different data sets. So just to say, I would like to search. So I search now for one of the parts here. And very simply, I get then a list with all the parts that fits to my search. I can also go in directly to the part to see more details. So here I can see descriptions, for example, what kind of different product groups, what kind of templates is available. Here we see the picture as well the 2D view for the layout. We also see for those who work with the 3D environment, Eplan Pro panel, also the available parts here. So once I have found the part that I need, I can also very simply just import it. In this case, I have this part already, so I can also update this one. You can, of course, do the opposite around from your parts database, check if there is updates for the part already in the data portal. So simply also the same, I place the component here and directly I have now my motor load switch placed accordingly. So with that said, let's also talk about the data consistency and the utilization of parts through electric P8. If I want to place, for example, this F6 motor load switch in my 2D layout, I can simply basically open first of all my page where I'm going to place the components. So here I prepared a very simple view of a 2D panel. And based on this, I have now the possibility to also open my device navigator, where I earlier synchronized based on the F6 part. I see also directly the part number, and I can simply just drag and drop this out here. As I place also the component on the layout, I directly also get in my enclosure legend, my F6 and the type number associated with this as well. So based on the same, as I said, with flexible design method, let's say that I need to produce my panel first. I don't have time to create my detailed design. I need to get this down to the panel shop so they can get started. And then later on, I will do my detailed design. Of course, this is also possible, utilizing the same principle, for example, the parts library, selecting the part and place it accordingly also here. So what I need to do though is also to associate now this part to the device that I would like to utilize. So in this case, we'll take F next and OK, which is here. So I have F8 with the same also type number here. What is now important is if I want to utilize the same parts also in my 2D design later on, I need to basically open again the page where I want to place this one, which is here. We see already I prepared an empty slot for this. And based on the F8, which I have in my device navigator, I simply just drag and drop. Again, we have a single source of data through the Eplan platform, and of course this is very simple to utilize between the different type of representations. So regardless where you are in the project of detail design, in single line or in multi-line or in the 2D layout, it's all seamlessly utilizing the same environment. So with that said, going through also the factor of generating reports. I mentioned earlier that, of course, based on the electric P8 environment, you can very easily create various different reports. Just to give you some idea, I'll open here, for example, one of our cable diagrams, which we see here. So we have a from to, and of course, you can also graphically represent all these in various different colors. We see here the type of stopper, how much you have to cut the sleeve, and so on and so forth. All these reports are completely out of the box from the system. No additional programming is necessary. It's all there to be used by the customers from day one. What I believe is also important is when you look at these type of reports, here is, for example, a cable overview. We need also to say that they are fully logical. They are not just stupid reports that is generated out of the system. They're also fully logical, meaning that when you look, for example, here on a cable, we see the factor that I have the ability to go in here. We can see and add lengths. Let's say, okay, this is 10 meters, for example. Directly we see the report is updating to 10 meters. We can also utilize, for example, the jumping function here to go to the graphics. And of course, in the graphics, we can also see here the 10 meters appearing at the cable. From the working process point of view, utilizing instead of going from the schematics, here I have all the cables. Very easily I can also update, of course, then directly each and every cable directly from here. I don't need to go through every step through the schematics. I very easily just work from here. And we see 10, 2 meters, and total. Of course, the report have the capabilities also calculating the total length. And of course, jumping back to just check that everything is okay to the schematic. Yes, also here 2 meters. So wherever you are, regardless, in the type of reports, in the bill of materials, if you talk about the detail design, multi-line, single line, and so on, it's all connected within the same data backbone. So this is flexible design methods from Electric P8, starting from either symbol or device oriented, from the assembly, utilizing data portal, working with typicals, all standard solutions out of electrical P8 environment. So, as I said, this was a short introduction to what you can see as a design method utilizing Electric P8. Of course, there is much more to see, but I hope this could give you some direction to the Electric P8 environment and what we can do utilizing the flexible design methods. Okay, so from that, is there any questions? Additionally, please ask myself and my colleagues. We are more than happy to give you feedback. And I would also like you to remind you that when you fill in the feedback form, you have, again, the possibility to win an iPad. So I really encourage you to do that. And that's all from my side. Thank you very much and have a good day ahead. Goodbye.